In this example, we're told that the mean incubation time for a type of fertilized egg at a certain temperature is 17 days, and we're told to suppose that it's approximately normally distributed, so think there that bell-shaped curve, and a standard deviation of 2 days. The first thing we're asked to do is pick the correct graph that models this normal distribution. So I'm going to click on the correct answer choice, and the reason this one's correct is because the mean is centered where we see the peak. That's where on the x-axis we should have the mean labeled, and then at those points of inflection we have a distance of 2, and 2 came from the standard deviation. So that's why that's the correct answer choice. Now from here, we're asked to find and interpret some probabilities. Now it does give you the standard normal distribution table, but because I see it says round to 4 decimal places as needed, I think I'm just going to use my calculator solely for this one. I definitely wouldn't want to use the 68, 95, 99.7 rule because that's not enough accuracy. So where it asks us to find and interpret the probability that a randomly selected fertilized egg hatches in less than 13 days, I can turn to my calculator, go to the distribution menu, that's underneath second vars. Again, this is a normal distribution, and I want to do a cumulative, the cumulative option, so CDF. And this is a less than option, so the lowest bound I'm just going to leave as it is in the calculator. The upper bound is 13, the mean was 17, and the standard deviation was 2. And that's how I arrive at this answer. So about 0.02. To interpret this probability, all of the answer choices, well, not all of them, but 2 of them anyway, refer to like 100 randomly selected eggs, or were selected, I'm sorry. So if I take that and multiply by 100, what this answer gives me as a whole number, 2, is what I would expect to happen as far as this statement. I would expect 100 would hatch in less than 13 days. So we're going to do something similar for part C, then find and interpret the probability that a randomly selected fertilized egg takes over 21 days to hatch. So I come back to my calculator, normal CDF. This time the lower bound is 21, and the upper bound, let's set it the highest, 1E99. Mean and standard deviation are the same. And I get this value. So let me type that in. And in a group, let's see, or not in a group, not in every group. It's very rare that we can say definitive statements like that, like always or never. So the better answer choice is A, that if 100 fertilized eggs were randomly selected, we would expect 2 of them to take more than 21 days to hatch. Now, a little bit quicker way to look at this would have been to have referenced that graph that we drew up here, because less than 13 days would be in this area, and that's the same as greater than 21 days here in this area under the normal curve. So I could have skipped typing in this information to get this information for this part C, but notice that I would interpret it kind of similarly to what I did in part B.